Okay, once again, good evening, everybody, and welcome to Adrien. And I turn the floor over to you, Adrien, to tell us about Griffon Hoverwork, a view from the top.
Okay, if you can let me share the screen now.
Yeah, let me, I will stop my sharing. And then one participant can share, so yeah, you should be able to share now.
Yeah, I'm still disabled by you, unfortunately.
Okay. Oh, no, that's me. Oh, right.
You there yet, Alan?
Okay, you should be.
Yeah,
no,
that's good.
Good. Right. Over to you.
Okay, hopefully that's working for you all now.
Yes, I can see it.
Good evening, everybody. A great pleasure to just have a quick chat with you this evening. I feel under an enormous amount of pressure because there's a couple of people in the presentation who have hovercraft companies for a lot longer than I have. I've been at Griffon Hoverwork for 12 years now. So I'm starting to learn how to do it. I didn't know quite what the assembled crowd were this evening. So I've got a bit of a general presentation for you that's got a little bit of why hovercraft, to just remind you what we're doing at Griffon Hoverwork, and a little bit about our historical setting and what our products are. And but then really a bit about the innovation of what we're up to, but not necessarily focusing on the technical innovation. There's a little bit on that, but it's really about what we're having to do to change the way the business works to fit into the context of where we are at the moment. Okay, so just to go on from there, you're all experienced hovercraft types, so you know why hovercraft fit into the world. But just sort of reminding you here that we go across the board, but the majority of what we do is in that bit at the top of the page there. There is something of everything in our market across that page. But really, it's mainly government agencies we sell to, and you can see a bit of a quick shot through the history of how Griffon Hoverwork has emerged, bringing together Hoverwork,
interested in this,
and Griffon Hovercraft, and John is here this evening, and fantastic legacy he left for us and supported us through, and also, of course, Malcolm as well, bringing in his expertise into the business as well. And a little bit, just very quickly, Malcolm will recognise this, these pictures at the top of the page here. Really, our focus is on low pressure skirts, and being able to get above the water, and not, as you can see, high pressure skirts on the bottom of the page here, like you'd see in a landing craft air cushion, where effectively you're using brute force to overcome the gradient and get over hump. We retain our product range right from the small hovercraft, sort of 4 to 5 man, right through to the BHT size hovercraft. We've got some designs developed bigger than that, and we're working with, and we'll come a little bit back to that later on. We're working with some military customers around the world who are very interested in that at the moment. And I think that's part of the sort of strategic context in which we're operating, that people are interested in. There's a better opportunities to sell that sort of thing at the moment. And so our market around the world is on here. The size of the dot sort of represents how much we've sold around the world. You can see we've retained one or two real hotspots around the world in India, Canada, a little bit in South America, around Scandinavia, around the Baltic, and in Korea, and our most sort of recent interjection in Japan as well, where we've sold 3 big ferry craft, and they're just starting the project to build those at the moment. And so the sort of background is we're a classic marine sector manufacturer, and you can see this is just across boat building across the board. You can see the volatility in boat building as compared to other industries is really significant. But we're a niche within that shipbuilding sector, within that marine manufacturing sector. And so our volatility is probably even greater than that 40% that you can see on that slide there. And so that's a shot of our performance over the last few years, and I look forward for a couple of years as well while we do the Japan project, which has been very good news for us. And so you can see that it's quite a difficult business model to sustain. And if you look at the context of where that is at the moment, I've got a few notes here, and I'll leave you to read through these.
Well, this is missing all the slides. It's giving lots of
You've got slides, do I?
Okay. You okay, everybody? Okay. So the background is, I think the sort of requirement for hovercraft is enduring. There is an increased requirement for an amphibious capability to support marine forces around the world. Lots of navies have landing platforms with docks in them. So and we've seen some emerge quite recently in Thailand and in Turkey, in Australia, in France and Spain and Italy, to name but a few. In South America is looking in Peru as well, looking at that capability as well. So it's quite interesting that has been a real focus around the world. One of the key points is that nearly all of the countries that we sell to want to move some of the manufacturing to their country, or a significantly greater part. In the past, you generally would have got away with an offset, so sort of selling something in the other direction to balance the winning the trade. But nowadays they want to move manufacturing into their countries. The UK banking sector doesn't really like manufacturing at all, and it likes marine manufacturing even less. So it's really quite a difficult environment from a financial perspective in which to work. And then there's a piece here which is really quite interesting, that I think diesel engines that we use are going to disappear over the next 10 years or so. Particularly difficult for the boat building sort of end of the marine sector, because sort of boat engines have always been a spin-off from automotive, and automotive is going to move towards batteries, and batteries really don't work in boats, let alone hovercraft, even worse for hovercraft. So it's an interesting challenge that we face from that perspective. I think, although I've got nothing to prove it at the moment, that feature of hovercraft, that they go quite fast for less power than a conventional boat, might actually start to become relevant again. And so that will be interesting when we get into some of the more expensive to implement clean energy sources. And I think what we have to do is within the business is wake up to the fact that actually there's not going to be any diesel engines, or diesel engines are going to be more difficult to sell as we look forward, and work out what it is we're going to be doing. And so what I'll do now is focus on a little bit of the sort of things we're trying to innovate in order, and some that we've already innovated, in order to try and fit ourselves for the future against this background here. And so we've always had some really good tactical problem solving people within the business. We've got a certain amount, but not a huge amount, of real blue skies thinking. And one of the attractions of being able to keep Malcolm with us is that he's one of those guys who can who will sit back and think of things with a really open mind, and comes up with ideas that just would never occur to the normal practical engineer. He brings that sort of inventor background with him. We can do a bit of stuff of borrowing from other sectors, and you'll see with some of the product development we've done in the last few years, that's some of the work we've done with varied success, and we can talk about that in a second. But the output is our product and where we're going to do, keeping ahead of the intellectual property, what we're keeping ahead of those who might want to copy us, finding other things to do other than hovercraft to sustain those lean years, and really thinking about how we model the business in order to deal with that volatility and the future in the context of those points which I just made. And so starting off with the product development, and one of the products we developed over the last few years, you'll be aware of the Isle of Wight route, which was delivered using the AP188. What we did was we studied the sort of throughput passengers and worked out what the optimum would have was for the size of the hovercraft. And so the aim was to develop something that would be a lower capital cost than the 188 to start with, that would definitely have a lower running cost, that would be cheaper to run all the time, that would give you enough capacity on it for nearly all of the time, but maybe not all of the time. That would be regulatory compliant with the latest regulations as well. So it was a challenging target that we set, but with quite a lot of work from across the board, I think, and we came up with a reasonable solution, which definitely reduced the noise by increasing the propeller diameter, came up with some more efficient ways of controlling the craft as well, which removed the need for the bow thrusters. The bow thrusters that were on there, we always said wouldn't be needed, but the pilots insisted we had those on there, and later on they were removed, so they don't have the bow thrusters anymore. They have significant control from the aft end of the craft with variable pitch and the cascaded rudders on that. So it's been very successful across the board. Clearly, when you introduce a new craft like this, its prototype goes immediately into passenger service. And so, of course, there's a whole lot of things to be developed all the way through, and there's some lessons we've learned about the way it was built, etc., which we'll be putting into practice. Now, we did try to reduce the maintenance bill by using quite a lot more electrical actuation rather than hydraulic actuation. And we took some electric actuators which had been very effective in industrial settings, but which actually proved to be not quite so reliable in a marine saltwater environment. And so some of those will be replacing back again with hydraulics when we put together the hovercraft with our new customer in Japan. With a lot of work from Malcolm, this was the first hovercraft to use the mixed flow fan. One of those is pictured there as well, which has given us a fantastic improvement in efficiency. That in turn means we're stealing less power for lift. There we can use a bit more of the power from the engines for thrust, which in turn meant with the increased efficiency of modern diesel engines, we could reduce the engines on board to 2 from the 4 that you would have on the 188. That was a significant saving, both in the capital cost of the craft and, of course, in the costs as well.
Adrien, could I just ask, hold it a second? It's just that I think Owen's iPad, it's not on mute, and sometimes we hear some noise coming from your direction. Owen, are you okay? You hear me?
I can hear you, and I will put it on mute.
if you wouldn't mind muting for a bit, thank you, Adrien. I think that'll make things more comfortable for you.
And so it's been a good solution, reducing the shore crew by dropping its own steps and ramps, so you can get people on board a little bit easier, and quite a pleasant sort of passenger experience, I think, with reduced noise, better visibility from the craft as well. And so overall, I think now that it's bedded in on that route, I think it's been quite successful. At the other end of the scale, we've looked at trying to get a bit more payload onto small hovercraft, and sort of started with the sort of plan form of the 470, this one here, the RNLI one. And you'll be aware that obviously when you've got no payload on board, you need to ballast the front of the craft if you've got all of your machinery at the back of the craft. And so we tried to overcome that by distributing the machinery around the craft. And we did that with a electric transmission, and with a diesel engine at the front and at the back of the 995 craft. We put a lot of innovation into this. So we glued the hull together rather than welding it. We used drop stitch side decks, which are inflatables that blow up into a parallel sided shape. We used the diesel electric system. We used the generators and the motors in this. The motors are in the hub of the propellers are from the automotive industry, and actually the ones we used, Yasa motors, were one of the only ones available at the time when we developed this. Now there's a far greater selection out there. We may not have selected that one if we were to do it now. So do I think this has really succeeded? I think it effectively proved the point. We got a bit more payload on a relatively small plan form. I think the drop stitch side decks are quite liked by our customers. I think the sort of overall design was quite liked by our customers. But actually, for a small craft in the setting that will be used by policemen, soldiers, rescue people, whatever else, what you've ended up with is something that is too technical for them to maintain. And you have to, and I think sometimes we always have to remind ourselves that we never sell a hovercraft to a hovercraft enthusiast. We sell a hovercraft to someone who just regards it as the truck that he goes to work in. There's a real another level to go to in this sort of design before it be robust enough for any of our markets. So it's been a very interesting exercise from that perspective, and it's taught us a bit about that. I think we'll have, for this size of hovercraft in the future, we'll go back to something more routine. But of course, the world is driving us to reach a more electrically centric solution. But we'll just have to borrow components and systems from the automotive market as they make it more reliable themselves. So the other one that's in development at the moment is sort of amphibious landing craft, so LCAC type size hovercraft. Clearly, the way that the US have gone is they've increased the power to go to the ship-to-shore connector. They have kept the size roughly the same because they still have to park it in the smallest of their landing platform docks. And so they've been forced on a very high pressure system. They've also attempted to introduce a certain amount of fly-by-wire, which has delayed their project by about 4 years. They're just getting the ship-to-shore connector into service now with Textron. But many of the amphibious forces around the world are not constrained by the same envelope as the smallest of the ships that the US Navy uses. So in particular, the sort of Navantia design of a landing platform has a much bigger dock than the smallest landing platform docks that the US Navy use. And so it's possible, if we take the most powerful diesel engines that MTU build for tanks, that a 6-engine model would work, particularly if the customer doesn't want a main battle tank on board that is as heavy as the American or the British one. And so many people around the world don't have that. And actually, marine amphibious forces have concluded recently that they probably don't really want to work with main battle tanks. And so that could work in our favor here to get diesel engines into here. We've also got the design developed to put in a gas turbine as well. But the preference is to try and really differentiate ourselves from what Textron are doing by achieving a diesel power. And that keeps the thing more efficient and cheaper to run for its life, cheaper to buy in the first place. And very importantly, for many navies, it means that they don't have to train any technicians to look after gas turbines because the diesel engine systems are in common with the rest of their fleet. Okay, so sort of moving on from the technical bit, a little bit on intellectual property. Of course, selling all around the world, and with the emphasis on having to build in the customer's country, we're always going to leak some of our intellectual property. And how can we go about looking after that? So we do have some patents. So those techniques that we used with the mixed flow fan and the drop stitch side bodies that you saw on the couple of slides earlier, we've got 5 patents on those, but they're only UK patents, and patenting them around the world is prohibitively expensive. So you can't really do that. And actually, when it comes down to it, all the countries that might copy your stuff would carry on and copy it, whether it's patented or not. It's a bit of double-edged sword as well. To get a patent, you have to publish some of the design, and so actually sometimes just keeping quiet about it is better route to keeping it under hat than putting a patent on it. Really, what we have to do to protect our intellectual property is to make sure that we keep at the sort of front edge of the market all of the time. and we work hard to try and do that. And in that way, if we're going to license a product elsewhere in the world, we can sort of effectively license the B model to that country rather than giving them our latest technology. So then, looking about the sort of commercial structure of the business, and John can sit and sort of chuckle to himself because he can see the whole thing going full circle as we discuss this. You've been aware, well, many of you have been aware that for the last 10 years or so, we occupied not just the little yard on the right there with the blue shed that was John's yard with Griffon Hoverwork, but also Merlin Quay, which is the sort of box on the left-hand side of that. So we had about 65,000 foot of manufacturing space there, which we did completely fill at one stage in the game. We had a big office, and we had our specialist manufacturing in the small yard at 8 Hazel Road, which was originally John's yard. And so, because we go through these cyclic periods, and because there may be many years when we only build in the customer country in the future, realistically, we are making our footprint such that it's as small as possible and matches what we're up to, but with the potential to expand out using various options like short-term leases of bigger manufacturing spaces, and as I mentioned, building in the customer country, because that's what the customer wants. You know, they're insistent, particularly in India, but South Korea will be the same. And I'm quite sure there will be other places that will be like that as well. If we export back to the USA, they've been like that since 1910. I think you've never been allowed to export a boat or hovercraft or anything like that to across the other side of the world. Okay, so at the moment, so we've got the small yard there where we've based some of our work and our skirt shop, but we've got a short-term lease on Trafalgar Wharf, and for example, we've got a strategic relationship with Goa Shipbuilding in India, who, if we have to build for the Indian Coast Guard, they will build for us. We've also got secondary relationships in India so that we can effectively compete against ourselves and avoid some of the trip hazards in the Indian procurement system. Okay, so and a little bit to finish off with now on how we're trying to diversify. So we've had the advantage that we've really been able to focus on selling spares and support over the last few years, and we've grown that market from about £2 million per year to this year it will be nearly £10 million worth of spares support across the world. We do a little bit of consultancy work as well. We're developing one or two major solutions for our customers, and we've got some work going on in the background for a simulator. We're actually selling some design to the wind farm boat market to assist them in building a surface effect craft. And Malcolm has done some tremendous work developing using the flexible structures capability we've got to work with universities to develop some flexible structures for wave power. And I think probably there's some more that we can do in that area. I think one of the things that's in the middle there, not just for our own product, but potentially for other marine products, we've got, because we work in hovercraft, which are a sort of quite specialist niche of the marine sector, but are regulated by the marine sector, we spend a lot of time working with regulators around the world to convince them that the hovercraft can fit into their regulatory framework. And so we kind of get to understand how to get around a lot of the challenges that you experience in that marine regulatory framework. And they will be very similar to the challenges of bringing in some of the new low or zero emission fuels like hydrogen or ammonia, and perhaps batteries as well, into any marine vessel in the future. So I think we can use some of our experience in overcoming marine sector regulatory hurdles in order to provide technical expertise across the sector. And that's one of the areas that we'll be really thinking hard about, is how we can use that experience across the board. But what we have to do throughout is make sure that we maintain the sort of fuel for that innovation by keeping as interesting a business as it's always been, despite the fact that we might have to do manufacturing on the other side of the world, which is the very interesting part for some of our people, but to keep pushing the envelope, to keep the really best people involved in what we do, because that's how we will be able to overcome all these innovative challenges. Okay, so that's a quick one through where we are. I will stop sharing so we can all come back in, and you can throw some questions if you would like.
Yes, so if anybody would like to start the discussion, please go ahead. Just unmute and let's start. Well, maybe whilst other people are thinking, one thing I was going to ask you a question about, and it's the pictures of the craft at Southsea, because I don't visit very often, obviously, and I saw the pictures of the craft with the electric side thrusters forward on some pictures, and then I wasn't sure whether it was the earlier pictures or the latest pictures where they don't have those side thrusters on. So if I understand you right, then it was found that they didn't need to have those, so they were removed, or what?
So Malcolm could probably answer this question better than I can, but yeah, we always assessed that you had plenty enough manoeuvring capability from the rudders and the variable pitch propellers to be able to operate the craft without the bow thrusters. But of course, we were selling it to a customer who used bow thrusters on the AP188 and the BHT for many years, and so didn't really have the confidence. So we put those electric bow thrusters on to start with. They had the same challenges in reliability as some of the stuff on the 995. It uses some of the similar systems, and so quite a lot of the time they weren't operational, and the pilots realised they never used them anyway, so we took them off. And so we actually got our own way in the end, despite our customer. Interestingly, our new customer in Japan, we have the same challenge. They had a previous hovercraft that had some little sort of puff ports on it, and so they want bow thrusters on it. And so we're developing a sort of, for decoration purposes only, very sort of small bow thrustery type thing that will leak a bit of skirt air out on each side, that hopefully they won't use in the slightest once they start using their hovercraft.
Okay, thank you very much. Anybody else for a question?
Yeah, just a quick one. When you talk about these bow thrusters, I was used to driving SRN6s both for the military and for hover travel, and I found for manoeuvring at very low speeds, they was almost instrumental in, you couldn't do without them. I can understand from a commercial point of view of going from A to B, and apart from inclement weather, to hold a steering course, not wanting them, just relying solely on your rudders and that. But to do away with them altogether, I can't see that. It's a bit beyond me.
Okay, but remember, you can use. You've got a variable pitch propellers as well, so you can use forward and backward thrust on the propellers. And so, I mean, a long time ago, that I watched a very good piece of film from over the top of John manoeuvring around a buoy. I think with in an 8000 or something like that, where you can actually at very low speed travel all the way around a buoy with your nose to the buoy, so going sideways all the way around using nothing other than a bit of skirt shift and variable pitch and the rudders. Now this has got cascaded rudders, more variable power from the variable pitch propellers, so you can effectively drive it sideways from the power that you get through the propellers.
Yeah,
Can I come in on that very, very briefly, Adrien? Just because we did some, I mean, I think the most interesting demonstration we did with an 8000 going into Southsea, following an AP188 with bow thrusters. This was right back when we were selling the concept.
Yeah.
They were having problems with a 188 because there was a tailwind and it was trying to weathercock. And the 8000 just drove straight in, just using rudders. And then it transpires that the 188 only had, I think it's about 25 degrees of rudder either side. And it took, you almost could time it with a calendar rather than, it took 10 seconds or something to get from lock to lock. And the 8000 had about 40 degrees of rudder angle and 5 seconds lock to lock. And the difference was like unbelievable. So the power of the steering of an 8000, you do not need bow thrusters. And it's been proven at Southsea. And, you know, I think the N6 probably had not that good rudders compared to a ducted prop nowadays. And I really think that is, Malcolm could probably agree with that, but he may wish to disagree, but that was my own experience of it.
We did some model trials on cascaded rudders, and as John says, the AP188 only goes plus or minus 25 degrees, and I suspect even with its 3 rudder setup, it would go quite usably beyond 30 degrees. But the extra rudder going to 4 equally spaced rudders means that you can generate significant amounts of side thrust without the air separating off the high lift side of the blades. Whereas as you go down to fewer and fewer blades, you end up with a situation where the flow detaches more easily, and it's not possible to go beyond, say, 20 degrees with a single rudder. And that improves as you put more blades in the system.
So we've been quite successful as far as that's concerned.
Yeah.
Not just with the one going to the Isle of Wight, but with all the designs.
Yeah.
That are, well, the 8100 is basically the same size.
Okay, could I just come in and open up a discussion on powering a little bit? Because you mentioned, Adrien, earlier on in your talk about the possible transition from diesels. What I'm hearing at the moment in the marine industry is perhaps that transition could be a lot more than a decade, on the basis of converting to the use of methanol, or call it e-fuel, which is a green fuel. Yeah. So by going to methanol, you can just use it in a diesel. You don't have to essentially change the engine. It might be a little less efficient than the current available engines. But if I understand it right, most of the high-speed diesel manufacturers at the moment are looking very closely into adjusted fuels, basically, rather than going completely going for, if you like, an electric option?
Sure. I mean, I think it's got to be bottomed out. So batteries don't really work in the marine setting. I know that even for the Thames Clippers, they aspired to make that a battery craft, and they looked at fast recharging. They looked at swapping out one set of batteries and another set of batteries as you arrive at each
terminal
terminus on the route.
Yeah.
They looked at flow batteries where you change out the electrolyte rather than recharging it, etc. But actually, what they've come up with now, which is the closest they can get, is a craft that runs on biofuel for most of the route, but for about 100 meters in the middle of London, it will run off some batteries. So it's quite challenging. I mean, I think methanol is one of the things. I think they will resort to. I'm not quite sure what they will resort to in big ships, but the challenge with smaller boats, boats is to find something that's of the same level of economy as diesel. Methanol is quite expensive. That's not to say they won't find a better way of a cheaper way of delivering it. Hydrogen is a good solution, but that is really quite expensive to produce at the moment. But theoretically, coupled with green electricity generation, it will become cheaper in due course. I'm quite ambivalent in the end about what it's up to. I think our space is not in inventing the power source.
Yeah.
Our space is to help with the integration of that. That's where we've got some guys who are used to trying to force a thing that's half aeroplane into a marine sector setting, and so that's quite a regulatory challenge. All of these other fuels are a regulatory challenge. When you think you wouldn't be allowed to put petrol in a
commercial
craft, let alone methanol, let alone hydrogen. So there's some real regulatory challenges to overcome from that perspective, and I think that's one of the sort of skill sets that we've developed by trying to force hovercraft into a regulated area, and possibly something that we can build some business from in the future.
Okay, I would like to, if you don't mind me doing it, bring Trygve in, because he's working in exactly this area just right now on a rather important project. Trygve, can you unmute and tell us a little bit about what you're doing with the zero emission craft? Hi, Trygve. You're still muted. At the moment, he's not answering.
This is zero emission.
Yeah, the zero emission Trygve. Okay, no, I'm not going. Somehow Trygve is not able to unmute at the moment. Trygve is working on the zero emission SES project over here, as in competition with 3 other companies, I might say. But Trygve already has the SES, which is partially electric, so it's a hybrid SES.
Yes, I've heard about it. It's interesting.
Yeah, the operators are relatively satisfied with it. We'll hear a bit more of that later on this year, I hope. But the zero emission competition for the coastal high-speed ferries is really a big challenge at the moment. So
Absolutely agree.
okay.
Yeah. Now, there's I think there's been some interesting work gone on in that. There's been a clean maritime demonstration exercise been going on. We haven't quite got the resources to be able to compete in that, but I know there is a hydrogen fuel small catamaran that will be in and around the Solent in the relatively near future.
Okay, very good. Okay, right. Any other questions, or do we want to wrap it up, gentlemen?
I was just going to say that there must be the use of a diesel engine at sea, or that sort of power plant has got to go longer than 10 years, just because, until something else comes along, because we're still going to have to use boats, whether high-speed ones or slow-speed ones, because the batteries won't last long enough.
Sure.
So it's got to be something. I think that the automotive engine base is going to be a real problem. So someone's going to have to take those old engines and keep them going or something.
Yeah, well, John, you're absolutely right. That I think the challenge for the sort of boat sector, as opposed to the ship sector, which will drive it, has the economy to drive its own change, is the fact that we won't get we won't have the spin-off from automotive that we had when we were replacing steam engines in ships, in boats with diesel engines. The diesel engines will be around for years, and we have to remain very aware of the fact that we'll be supporting hovercraft around the world with diesel engines in for many years, and we'll have military customers who will have a get out of jail free and will be wanting diesel engines. The challenge will be, where will you get new diesel engines from?
Yeah.
I mean, our customers around the world are gobsmacked at how expensive diesel engines are nowadays already. That's because you can only buy a very clean diesel engine that's a common rail tier 3, 4, whatever, which is hideously more expensive than the air-cooled Deutz engine that they're using at the moment, or whatever. Yes, and they just can't believe that these things have got so expensive over such a short period of time. But that's the way it is. But I can see we won't be able to source new diesel engines in the foreseeable future. So we've got to have that alternative. And then we've got a selection of customers who already don't want a diesel engine. Yeah, so they're already saying, can't you do something other than diesel? Which is interesting, particularly interesting in a hovercraft. I think it's pretty challenging in a boat, but very challenging in a hovercraft. But there we go. You know, we need to wake up to that, work out what it is, and so there's plenty of pressure for us to try and innovate in that space. I think part of the secret there is to capture a customer who's rich enough to help us on the journey.
I think one of the solutions that the aviation industry is looking, or having to look harder at now, is sustainable aviation fuels.
Yes.
Now, unfortunately, the minimal quantities that have been generated at the moment or manufactured are based on old cooking fat and crushed beans. But there may well be in the future a method of synthesizing diesel fuels and kerosene.
Yes.
Using carbon component from either captured carbon or recovered carbon, and the hydrogen component from electrolysis.
Yes.
I've little doubt it's going to be about 3 times the price of aviation kerosene at the moment, if not more. But it may well be the case that the aviation industry will have to just swallow the extra cost and major on SAFs rather than trying to invent fuel cells for aircraft or batteries both of which are certainly at the moment are far too heavy.
Yeah, absolutely. Yeah, absolutely. I mean, I think aviation will branch off to be really much more expensive in the future, as you say, Malcolm. Where we're sort of caught slightly in between the two, but the fact is that the customer expects it to be more in the price range of a boat than an aircraft. It's one of the challenges of selling in this sector, and so I think we're going, that's another driver for us to be at the sort of cutting edge, if you like, of what's possible with something relatively economic.
Yeah, and as you mentioned, Adrien, the 995, the hybrid craft with rather more complex electrical components, operators already find that quite a challenge. So the basic ICE internal combustion engine is something people are comfortable with.
To tell you the truth, even a common rail diesel engine is too complicated for many customers around the world in the sort of the way it will be used. Yeah, really, you'd love to go back to a diesel engine that's got no electrical components in except a starter motor, perhaps an emergency fuel shutoff valve, something really sexy like. It's the modern diesels are so finicky when it comes to the diesel you put in them, that is the biggest one of the biggest challenges we have with selling around the world, because immediately our customers put something other than diesel in them. And I'm not talking about a state-of-the-art zero-emission fuel. I'm talking about something that's mostly water and moss. And then we're in all sorts of trouble. But yes, the 995. Malcolm, have you got the latest from the guys at the university? I think when we first did that and thought about how far it would go with the battery, and it would have gone for about 15 minutes if you replaced all the way to fuel and engine with battery. And I think now battery technology has come on far enough for it to do just over an hour.
That's where we are at the moment. The university are busily working on all the control theory and trying to produce a computer simulation of the way it will work and the way it'll consume energy. So they're on their second year of doing it now. They've passed on to the new team, and hopefully we'll have something useful in the way of software come May time, I think. And they're also attempting to make a test bed as well.
Yeah. So a small utility hovercraft might feasibly be battery. Yeah. So giving you an hour or two of going to do a rescue that doesn't go on too long, or whatever. Or something like that. I mean, the other thing is, of course, as electric becomes commonplace in automotive, the electric end of it, no matter how the electric is caused, becomes more mature and hopefully more reliably transferable to what we have. What we did in the 995 is actually completely unique to us, because we're running without a battery in the system at all, and so you've got a whole load of other things. Weirdly, the bits that are unreliable in the 995, once you've completely set it up, are mostly mechanical things like hose clips and leaks and stuff like that, which you overcome in the automotive sector on coolant circuits and things like that. You overcome in the automotive sector because you make thousands of them, or hundreds of thousands of them. But when you only make 2 or 3 of them, then it's more difficult to do that. But all of those things are so much more critical with the sort of systems we're talking about, where you know the criticality of keeping the electric machines cool is immense, and as soon as you lose a tiny bit of coolant, you've got seconds before the thing is destroyed, and you've just got rid of something that cost half the cost of the whole hovercraft. Yeah.
Okay, yeah. Somebody else want to come in?
Yeah, can I ask a question? Hello,
course,
Adrian.
yes.
Hello, everyone. Apologies before if I wasn't muted. Just a question about the interface between your generator on the 995 and the motors. As you said, you don't have batteries to in between those. Have you solved those problems? Because I seem to recall John telling me many years ago you had a lot of problems initially with that.
Yeah. It only took us about 3 years, so it was done in an instant. Yeah. So yeah, I mean, the same as the application in most cars. So you generate in well in this case you generate in variable 3-phase, then you go through a power electronic controller. Then you use then you've got it into DC. Then we control that with a small computer, which happens to be in the back of the control panel, the Murphy screen in the hovercraft, and then you put it back into an equivalent power electronics box of tricks, which then turns it back into variable 3-phase. And puts that into the motor at the back. The motor is extremely reliable in the hub of the propeller. Yeah, and that's obviously the normal setting for that electric machine. The generator is a very similar electric machine, but obviously used the other way around. And obviously it wasn't quite designed for that in the first place, and so it's not as reliable. But there were all sorts of things that you never would have thought of that you came across. And the back EMF, the torque that you got, was sufficient to break the crankshaft. And so for a bunch of us who are primarily mechanical engineers, so Malcolm's an aeronautical engineer, and John is a mechanical engineer, and I've got naval architects and marine engineers. My background is aeronautical engineering. You kind of think about electricity as being a bit sort of whiffly, but actually when it's doing it properly, it's pretty stern, and yeah, it beat the engine on many occasions. So it took an enormous amount of tuning to be able to get that right. If you ask Tesla or any of that crowd, did they go through the same epic? They'll go, yeah, but then they prototyped it over many vehicles. We had one go at it, which was going to be sold to a customer. Well, actually, funny enough, we did do one prototype that we never sold to a customer, and we did one other prototype that we sold to an insurance company, which I thought was quite good at the time.
Very good. Could I ask, and perhaps others who'd like to come in? You showed us pictures of the craft, a little bit like the LCAC.
Yeah.
So, and you mentioned that other navies don't have the same constraints as the US. Could you tell us a little bit more about that?
Yeah. So it's interesting. So we're speaking to probably 8 nations who sort of come and go according to what's going on.
Yeah.
But lots of navies around the world have decided the most sort of pragmatic ship to have is a thing that's a bit like an aircraft carrier, but it's got a dock in it as well. So LPHD, multi-role, amphibious naval platform, or whatever. Mm-hmm. And they're sort of coming down to the Navantia design across the board, which has got a much bigger space in the back of it than the original LPDs that's, you know, like Intrepid and Fearless, or like the standard, the old LPDs that the Americans have got. So you can have a bigger planform hovercraft in there, and using the most powerful and compact diesel engines, which are tremendously expensive, but they're tank engines, then you can just about get away with a substantial payload and a properly performing hovercraft by increasing the planform, not significantly, but a bit. As soon as you start to constrain it, you're out to lunch again, and you've got to go back to a gas turbine. And so it's interesting. The design that Textron built is owned by the US Navy. So it's a design that was issued to Textron to build, and they just had to perfect some of the systems within it, in particular the controls, the sort of fly-by-wire control systems, the software. And so that's extremely constraining if they sell that to other navies around the world. Apart from everything else, it's very expensive, but it means that you can't modify it. You're at the back of the queue for spare parts after the US Navy. If the US Navy decide to upgrade it, then you've got to upgrade as well. You might not be able to afford it. It might not fit in your ship. If they upgrade it at that stage, it might not. It might, if they upgrade it and use up some of the space on the deck, you might be able to fit your kit onto it. And so you're not allowed. You have to have the American one or nothing. Yes, and that's the way it goes. And of course, and so it's quite attractive to some navies around the world to have something that will compete with that. I don't promise that we'll ever get there, because we haven't got one to show off. We'll never be able to afford to make one to show off to those guys. But there is a couple of armed forces around the world who are very enthusiastic about not having to be tied to the American shirt tails, and so that's where we're pushing.
All right. Well, certainly wish you all the best with that. Okay. Once again, anybody questions or silence? Okay, then I'd really like to turn it over to Mike to bring us to a closure. Mike Mooney, would you like to unmute Mike and close the meeting?
Yeah. Adrien, thank you very much for a very interesting talk and discussion. It was actually nice to see so many different people on this occasion as there was in the last one when we had the initial Zoom meeting. I can only thank Alan for organising it, and thank you once again for participating.
It's been a pleasure. Thank you very much, everybody.
No worries.
Yeah. Thank you, Adrien. That was very good.
No problems. Thanks, everybody. Bye-bye.
Okay.
Bye.
Thank you, everybody.
Bye-bye.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Thanks a lot, and hope to see you all at the next meeting. Okay, Adrien, would you stay with me for a minute? Thank you very much for coming on, Ingvar. I would really like to take contact with you a little later on to talk about your R&D, if you can hear me. So thank you very much, Ingvar. Okay, there he is.
Yes, I can hear you.
Yeah, and it's been a little bit of a. Oops, sorry. That's
No, it's John Hall.
Yeah. Okay.
It's John Hall calling.
Well, maybe I'll just say then I should have got in contact with you much earlier than this, but I'll try giving you a call in the next few days to have a little chat about the current status of the R&D and your plans in Antarctica.
Yeah,
that's okay with you? Yeah.
Yeah, that's fine.
Yeah.
We're very much looking forward to it because
Yeah, yeah.
I've been down there a number of seasons, and you know, what struck me was that the ice shelf in Antarctica is a primary hovercraft country. You know,
Yes,
it would,
yeah.
and so we'll see.
Right.
what happens.
Yeah. Well, I'll leave you to John, and thanks, John, for coming on board tonight as well. Yeah. See you soon.
Bye-bye.
Bye. Okay. So, yeah, Adrien, yeah, saw your message earlier on, and hope the bank side of it sorts itself out.
Sure it will. Just the formalities of going through it.
Yeah. Okay.
I've also now got, in theory, got the online bank come through today.
Yeah.
And I don't know if you know what business do these days with Lloyd's Bank, but I've got this little device I have to use. And this,
Oh, yes, yeah.
and a card, you know, as well, before I can exit